Right, so this is where I stopped. So with this, I want you to know basically how does the blood get returned from the heart. So how does the heart drain its own blood? So the comes from it enters two places. So one of them is 20% of it goes right into the right ventricle. Okay, so all the deoxygenated blood just dumps into the right ventricle. Okay, now 80% of it goes to the right atrium and it travels down one of these three veins. So there's a great cardiac vein, which is on the front of the heart, the middle cardiac vein, which is on the posterior of the heart, and then there's a coronary sinus, which is a sinus is a large, wide, like floppy vein. It's very kind of big. Think about like a sinus in your skull. It's a space. So the coronary sinus is right up at the top of the left ventricle. So a whole bunch of blood flows into there. So that's how the blood drains from the heart. Okay, so you guys are going to learn these in lab. So coronary vessels, they're much easier to see on a three-dimensional model than they are on these pictures. So, okay, now, when the heart is beating, what's going on with those vessels? So when the heart is contracted, okay, the vessels are all compressed. Okay, when the heart is relaxed, the vessels are open and the blood flow is increasing. Okay, so when it's contracted, you're getting less blood to the heart. When it's relaxed, then the blood is flowing to the heart. Okay, now we want to talk about, we want to get more cellular. We want to take it down. My phone keeps ringing. Take it down a level and get to the cellular level. So we're going to talk about cardiac muscle cells. Okay, so the structure of the cardiac muscle cell is going to be really important to allowing the heart to beat as a unit. Okay, so the structure of these cells is what's going to keep it beating all together. Like you don't want the top beating or part of the ventricle beating. You want all the muscles in the ventricle to contract at the same time. So you want to have like everything, or both ventricles even contracting at the same time. So you need them to contract together. So if you think back to histology, which is the beginning of Bio 103, you looked at slides of cardiac muscle cell. So you should know that cardiac muscle cell, the cells are branched. Okay, so you can look here and you can see the two branches. Okay, they're intertwined. Okay, so if you look at them, there's going to be cells all kind of overlapping. Okay, they're going to be branched. Okay, the other thing is they're striated. Okay, so they have sarcomeres. Okay, now the connections between the cells. Okay, the connection between the cells are called intercalated discs. Okay, and they're mechanical junctions. So basically, here's the disc, and here's a disc. So here's one that's magnified. Okay, so it's where these cells are going to connect. Those are intercalated discs. So in those discs, they have two big main features. So one of them is desmosomes. And desmosomes, they work, it's like stitches that hold those cells together. They're going to keep them from pulling apart. Okay, so it's going to keep the heart together. Okay, and then the other thing is gap junctions. So gap junctions are these little channels, okay, or spaces where there are a whole bunch of channels between the cells that's going to allow ions to flow quickly from one cell to the other. So all the cells are getting the message at the same time. So it's going to increase the speed of cell communication. Okay, now, cardiac muscle cells don't go through mitosis. Okay, so they don't go through mitosis. So that's why a heart attack is so damaging, because it causes permanent scarring. Okay, now, cardiac muscle goes through aerobic respiration. Okay, so the metabolism is aerobic. It doesn't go into anaerobic. Here's a slide. So here's the intercalated discs. Here's the striated muscle, and you can see it's branched. Okay, it has lots of myoglobin. Okay, so myoglobin is important for oxygen storage. Glycogen is how we store glucose. The mitochondria in the cells are very large. Okay, so they're really good at cellular respiration and making lots of ATP so the heart can keep beating. Okay, cardiac muscle cells can use fatty acids, glucose, and ketones to keep aerobic respiration going. Okay. One important feature of cardiac muscle cells is that, one feature is that they are fatigue resistant. Okay, so if you're fatigued, you're tired. Okay, so heart muscle doesn't tire. Okay, you never feel a burn. It never goes into anaerobic respiration. The cells and the tissue is designed so it doesn't tire. It doesn't become fatigued. It doesn't go into anaerobic respiration where lactic acid builds up. Okay, so I have on here, think about it. You never feel the burn in your heart when you're exercising like you do in your skeletal muscle. So if you're doing a whole bunch of squats, right, your legs start burning and going into anaerobic respiration, but your heart, who's exercising at the same time, doesn't do that. Okay, so more important features of cardiac muscle. Okay, now we're going to stop here because this is like the end of that set.